Soon as this decides to behave, there it goes. Like I said, there's a lot of math on this test. A whole lot of math on this test. You do need to know the relationship of pressure, volume, and temperature to each other. That's just the top of the review that I'm not going to go over. I'm going to focus on the math for today because it has been a while since we've done some of this. Since first one says how many moles of oxygen are required to completely react with 8.25 moles of acetylene gas. Okay, this is acetylene gas. Okay, and it reacts with. It wants to know how much oxygen is going to react with exactly this much of my starting substance. Okay? If it is a mole to mole conversion, it is a one step. Where should moles of the acetylene go next? Down, over and down one. And then it's asking you to change it into moles of oxygen gas. Where do these numbers come from? I mean, this is what you start with. I've got holes here. What goes with the moles? Yeah, so the two in front, the two in front of the acetylene in the equation is going to go in front of it. The 5 in front of the oxygen gas is going to go in front of that. I mean, moles of the acetylene are gone, so it would be 8.25 times 5 divided by 2. And if I round it to 3 significant digits, I get 20.6 moles of oxygen gas. So this would be when you go off, if you do chemistry in college or grad school or whatnot, you're actually going to calculate how much of your reactants should be perfect to react with each other so you're not wasting anything. Honestly, are you ever going to use math like this ever again in your life? Probably not. Okay, but it's the same concept would be used if you were baking something. You don't want to have a bunch of extras that you're going to end up having to throw away. So now, normally, if you do this in college, it won't be in moles, it'll be in grams. Yeah. Are there any questions about a mole-mole conversion before going to the next one? Or is anybody still writing this one now?
I'm going to write it down.
What's that?
Jimmy, okay. Was I talking to you?
Let me do attendance then while you guys are getting caught up. Let's see. I don't see George. What's up here? Didn't see Declan yet. Maybe just a second. I need to get us in a little. Sebastian's here. Caitlin's here. Yeah. Reagan's online. Aiden's here. Valerie's here. Raiden's here. He's right there. All right, are we ready? Okay, I'm gonna go forward, y'all. I don't have enough time to wait. You also have to be able to calculate molar mass a lot. Okay, when you have a mass, like limiting reagent, percent yield stuff, you're gonna have to be able to do masses of compounds. So I have 2 aluminums. I pull out a periodic table, which I'll have these for you guys tomorrow. I've got to pull them out. Each aluminum is 26.98. I have 2 of them, so the aluminum portion of aluminum sulfate is going to be 53.96 grams. I originally had 1 sulfur, but the 3 multiplies everything inside. Each one I think is 32.0 something. 32.06. And then I have 3 times 4, which is 12 oxygens. Each one is 16. So what do? You add them together. And so 1 mole of aluminum sulfate is going to be 342.14 grams, or the way that the unit is supposed to be grams per mole. That's how many grams are in 1 mole of that compound. You have to be able to calculate molar mass. It is all over this test. Most of your vocabulary is like kinetic theory of gases stuff. Like they have a mass, but they don't have a definite volume. Gases like to move randomly. They're not attracted to each other. Like all of that stuff. a whole bunch of kinetic theory of gases is on the test. Okay, so are there any questions with calculating molar mass considering it's all over your test? Yeah, it's fine. I'm not trying to go too fast, I promise. I'm not even sure how many questions it is. It's probably like 15.
It's
It's
not
just,
bad. You got writing as fast as I used to.
well,
Yeah.
I just want to write 20 words literally within 2 minutes.
wait, do what?
I used to want to write 20 words within 2 minutes.
Teach my mom.
What?
Are we ready? Okay, we'll go forward. The next one that you have, it's starting off with 250 grams of oxygen. It says that it's excess acetylene gas, y'all. Shh. If something is in excess, it's not going to be part of your math. If he says it's in excess, ignore it. So I am starting, it's the same balanced equation. I am starting with 250 grams, but now of oxygen gas. And I want to know how much carbon dioxide is going to be produced. The acetylene gas, once again, has nothing to do with this problem because it's in excess. That means that the oxygen has to be the limiting reagent. So I know I'm going to need the mass of carbon dioxide and oxygen gas. Carbon dioxide is 2 times 16 plus 12.01. Oxygen is 2 times 16. Uh-oh. It's okay. I'm just going back and forth. So just like the other one, you're going to start by putting that provided, given, known, whatever you're familiar with calling your starting substance in the top left-hand block. And then I'm going to bring its unit, grams of oxygen gas, down. Okay, if I'm in grams of oxygen gas, the only thing I can change it to is to 1 mole of that gas, where the mole's gonna get a 1. I just always do my numbers last, which is great. If I was just going between grams and moles of oxygen gas, I'd stop, but I need to switch it into something else. And this tends to be the part where people get stuck. You switch between different substances by using the coefficients of the balanced equation, which was the previous problem that we just did. Well, not the molar mass, but the previous one we just did. And then you can go from a mole of any substance to its grams by using its molar mass from the periodic table. I liked mass conversions because these were always ones. The balanced equation told you this. The only thing you had to do was to calculate the masses of the substances. So 1 mole of oxygen gas is 2 times 16, which is 32 grams. The oxygen is going to get a 5. The carbon dioxide is going to get a 4. And then 1 mole of carbon dioxide is 44.01 grams. Everything cancels out except for grams of carbon dioxide. On the bottom, I have 32 and 5. I know a lot of you are multiplying the top, writing out an answer, multiplying out the bottom, writing out an answer. If you're doing that, that's okay. Just don't round excessively. It is better to let the calculator do it for you by using parentheses. But if you do put this in the calculator, it's just going to go away. Ones don't count, so it would be 250 times 4 times 44.01 divided by, you would open parentheses, 32 times 5, and you close it and hit enter. And with 4 sig figs, I get 275.1 grams of carbon dioxide. Whose music is like killing their eardrums right now? Stop that.
If your music is not killing your eardrums, then you're
You're not
not
listening
listening
to it
music,
right.
right?
Okay, well, then so enjoy the inability to hear in your 30s.
Oh my God.
Because once you break the hairs off in the inner ear, they don't grow back. Okay. All right. Okay, are there questions? There should be lots of 3-step mass. They're not really hard. It just takes a bit to, you got to calculate these. I'm assuming that most of your equations are already balanced. Next week, we do need to be able to create skeletons and balance them again. When we do because we're about to do acids and bases.
Acid.
Mm-hmm. Acids and bases, hydrochloric acid, sodium hydroxide, those things, ammonia. Huh? No,
I was thinking, that's probably like that.
no.
It's supposed to articulate.
You like pedophile.
No. All right, so you also have to be able to identify a limiting reagent. Okay, if it's, now I don't know the way that they're gonna ask this. If it says that something is in excess, and the other thing is the limiting reagent. Reagents are the things that you start with. Okay. However, I'm pretty sure they're gonna ask you to compare both reactants and figure out who runs out first. I don't know which way they're gonna ask this, but I do know that limiting reagents are on your test. So you can pick one. Doesn't matter, pick one. So I'm just gonna pick, and you're gonna have to use their masses from the periodic table. I'm pretty sure I picked the sodium, I did. So the first thing that was listed, I have exactly 5 grams of sodium, 5 grams of chlorine. One of them is going to run out first. It really does not matter which one you choose, but whichever one you choose, you're going to compare it to the other one that's provided. And your answer to your math is how much you need. This is telling you how much you have. You either do have enough or you don't have enough. So I have to go from the sodium to the chlorine. I'm going to figure out how many grams, because it says I only have 5. This math is going to tell me how much is necessary. So you're going to go from grams of sodium to 1 mole. We're going to use the balanced equation in this next part. And then 1 mole is going to be the molar mass for chlorine gas. Sodium is just 22.99. There's no subscript. The Na gets a 2 and the Cl2 gets a 1. That's from the balanced equation. And then 1 mole of chlorine is 70.90 grams. And so that's everything out. I so just took these from notes that we did. Okay, so it would be 5 times 70.90 divided by, and then you would use parentheses, 22.99 times 2. And I'm going to have 3 numbers because 5.00 has 3. And like I said, I have 5 grams of sodium. I'm figuring out how much chlorine would be 100% perfect for exactly 5 grams of sodium. According to my math, I need 7.71 grams. That's what that multiplies and divides out to. I need 7.71. I have 5. Do I have enough to cover this?
No.
No. So that means that is the limiting reagent. If you would have had more than what your math said, then that would have been an excess, and the other thing would have been the limiting reagent. Now, I did see some people when I was grading your work, you actually worked both problems out. Like you did the 5 grams of sodium to the sodium chloride, and you did the 5 grams of chlorine to the sodium chloride in grams, and whichever one's the smallest amount, that's it. That'll work. It's just you're doing an extra problem that you don't have to do. Okay, so you only have 5. You do not have enough at all. So chlorine is limiting. That means sodium is in excess. I just don't know how they're going to ask it at all because most of my chemistry classes are evening classes and they don't let us see the test
So
beforehand.
Cl2 is limiting.
It is limiting because when I did all my math, this is what it came out to. And the answer to your math is how much is needed. But I only had 5, and so I didn't have enough to cover the 7.71, which means that the chlorine is the limiting reagent.
Are we allowed to use our notes for the class?
The paper that you're doing right now,
Or not that,
no, because what'll happen if I do that is you're going to spend so much time going through your stuff, you're going to run out of time to take the test. This puts, at least the mathematics, it puts it all together for you.
What if I could go through the room or something?
No, I can't let you, no, all the chemistry teachers do the same thing. I mean, I could say you don't get to use anything on the test. So, all right, if you begin with 58.9 grams of zinc, okay, excess chlorine means chlorine is not part of the problem. What is the theoretical yield of zinc chloride in grams? And then secondly, because this is a percent yield, the answer to this is my theoretical. This is my actual. So this is going to be 2 different ones. So excess chlorine is not important. I wonder if I did the percent yield part on the, I bet you I didn't. I may have to drag that into, here, let me freeze this. I have a feeling I did not put the percent yield. not actually in here. Yeah, I did not. Okay, and then I gotta go into stoichiometry. Hold on. I just realized I only did the first half of the question. It'll take me 1 second to locate it. Stoichiometry. If I can find it. That's gas laws. Well, here we go. Copy. Hold on, I'm pasting my stuff over right now. Oh, good Lord, this is, yeah, it's open right there. As soon as I can figure out what I did with my slide. All right. Let me go back to where I was. All right, so you're going to have that 1 mole of zinc. You're going to grab its mass off the periodic table, which is 65.38. There's only one of them. The zinc gets a 1, and so does the zinc chloride. It just so happens to be 1s from the balanced equation. And then 1 mole of zinc chloride, 65.38 plus 2 times 34.5, I think it is. I don't remember chlorine off the top of my head. Okay, so when I calculate this, I cross out the ones. 58.9 times 136.28 divided by 65.38. My theoretical yield, I should be able to make 123 grams of that substance. Okay, once again, the answer to your math is your theoretical. This is how much I really made. And to do percent yield, you do the amount that you make divided by what you should have made times 100. And there should be 2 numbers after the decimal. And that's what I just pulled from my old notes as I pulled the second half of this over. Your percent yield can never be over 100%. If it is, you either messed up your math or you flip-flopped these. But the answer to your stoichiometry is, once again, it's the bottom number. It's your theoretical yield, which is what TY stands for. Okay, so same problem. So, oh, you need to go back?
Yeah.
I'm sorry, I'm sorry, that you're good. It's just, this takes 2 slides to do. I'm not, like I said, I'm not trying to go too fast, but this is a lot of stuff to get through. Oh my Lord. 123. Okay. Are y'all ready? Yeah? Maybe? No? Okay, so still the same problem. But if I'm asking for percent yield, what's circled in green is my actual. My math that I just calculated was my theoretical. And to calculate percent yield, it is actual, which should be the smaller number, divided by the theoretical, which is the answer from your math on the previous slide, times 100. And when I do put this in, I get 93.50%, which is actually extremely good. It's not like, if you're the lab, like the actual tech, that's not good. But if y'all can pull one of this off, that's not too bad. I'm not saying anything bad, it's just you don't. There's all these different things that we do with chemicals to make sure that you're not wasting anything. My nose is so itchy.
I go to the bathroom. I couldn't breathe.
I can't breathe. It's the pollen. Like it feels like I need to blow my nose, but there's
This
nothing.
makes you thirsty.
Huh.
I'm thirsty.
You're not gonna swear about it.
It's just frustrating.
Kind of breathe, I don't know what it is. You want to die and snap or something.
All right, we are about to switch over to gas laws. Most of you actually did fairly well with gas laws.
Not really.
Well, I mean,
Hey, shut up.
they're, most of them, it's proportions. Oh, you don't have to worry about what's down here in blue. Just if you're getting over 100% for your percent yield, you have done something wrong. Either you didn't get your theoretical right, or you flip-flop those two things. We have a gas law. This is Dalton's law of partial pressures, where the total pressure of a gas, you add up the individual partial pressures. That's it. If you know the total and all but one of the partials, then you're going to add the partials and subtract that from your total. In this case, I know my total pressure is 302.5 kilopascals. I know two individual pressures of the three. What I do not know is mystery gas X, whatever that is, the remaining air in said system. So you would add these and subtract them from 302.5. And it should be 92.1 kilopascals. There's really not much to Dalton's law of partial pressure. I mean, I could make it evil. I really could.
Don't be like this.
And make you do like the ideal gas law and then calculate like the individual partial pressures
Hold on,
first
I'm not there yet.
and then do the total. But that's not the way they teach it here. That's the way I used to do it though.
Don't move it yet.
I'm not. We're gonna do one of each of the gas laws. And I'm hoping I can get through the whole thing. If I can't, we have what, till 11:55? Not much. Y'all ready?
Democracy is.
It's the bell schedule, does this every 6 weeks.
I will
But I
remove
actually
it.
like this class though.
How about our fifth one?
Huh?
Somewhat.
All right, y'all are ready. All right, next one. You can go back.
Volume and temperature.
Temperature, I don't like temperature.
Next one's volume and temperature. So that would be Charles' law.
You give us,
I don't know.
I don't know how it is on this test. I need to ask, of course she's not here. The only one of the chemistry teachers that saw the test, she had to take her kid to the doctor.
can you go?
I'll send her a text and see. I am not a fan of making my students memorize equations. You need to know how to use a formula. So I don't know.
What gas law is this?
Huh?
What gas law?
For this is Dalton's law of partial pressure. This is where you add and subtract. Like there's not much to it. Now this one is Charles's law, which is the relationship between temperature and volume. You have to make sure you're in Kelvin. If it's already in Kelvin, awesome. If it's in Celsius, you need to add 273. So these go together. You need to add 273. I'm going to count these my ones, and I know my T2. What I do not know is my second volume. Now, with the little lots, like not the ideal. If they're both in milliliters or they're both in liters, it's no big deal. They just have to match. If there's pressures have to match. The ideal gas law is the one that has to be in liters. It has to be in atmospheres. Like they all have to be in Kelvin. And this is essentially a proportion where you're going to cross multiply and divide by the thing that's left out. So multiply these, divide by that one. There's not, I mean, if you really need to rearrange it algebraically, lovely. But I mean, even if you were solving for down here, which I know it's on my hand, you would cross multiply and divide. It just depends on where is your unknown variable. What is it that you're solving for? So it would be 4 times 331 divided by 297.
4.5
Yep, so, and I'm gonna round it to what, 200, so 4.5 liters, yes.
What's this on?
Are there questions about Charles law? Charles law and Gay-Lussac's law are set up the same way. It's just Gay-Lussac's is pressure instead of volume. All right, let's go to the next one. We've got volume and pressure. This is Boyle's law. This is V1, P1, P2. What I do not know is V2. And Boyle's law says if the pressure goes up, then the volume went down. They're in Boyle, B-O-Y-L-E, Boyle's law. Now, you don't have to rearrange. I mean, some of you put in numbers first, and then I can tell by the way you write your stuff down when I check your papers. But you know both of these. So the ones that you know both of, you multiply them and you divide by the other one. It's not, I mean, it's technically not a proportion.
I have a question.
What?
So on this exact gas law, do we like multiply on the top and divide by what's on the bottom?
For this one?
Yeah.
Yeah. You're either going to know both ones or both twos.
Okay, what
Multiply those and then divide by the other thing that you know.
if you didn't know P1?
Then it would be P2 times V2 divided by V1.
That's cool.
If you're solving for P1, divide both sides by V1 to get it out.
Yeah, so you would multiply two on the bottom, divide by the one on top.
You would, if you're solving for, we say P1 or V1? V1? You divide both sides by V1.
Yeah, so you multiply
Yes.
two on the bottom, divide on the top.
Okay, yes.
But I should be like cross multiplying.
No. No, because this is technically not a proportion. When it's,
So you don't ever cross multiply on this one?
not on this one.
What law is this one?
This is Boyle's law. B-O-Y-L-E-S. All right, Gay-Lussac's law.
Wait.
What?
Hold on, can you go back to the last one?
Here?
Yeah. I'm just gonna write down.
Gay-Lussac is G-A-Y-L-U-S-S-A-C. I'm sure I'm not pronouncing it right because he's French, or was French. He's dead now.
Can you go a little before that?
Go on before this.
Yeah.
I got 3 parts already, so I'm set with parts right
Okay,
now.
got it?
Yeah.
All right, so let me go back. All right, so this one will be Gay-Lussac's law. We've got pressure and temperature. In this case, we're solving for P2. We're not going to change it out of kilopascals, just the answer is going to be in kilopascals. Gosh, I don't even know if they ask questions that it goes to standard temperature pressure. I don't know. I wish they would at least let us give them input on what goes into these tests. So anyways, Gay-Lussac's law says P1 over T1 equals P2 over T2. Yes, you have to make sure you're in Kelvin. It does not change. And this is going to be a cross multiply and divide thing. So multiply, divide. Anything that's diagonal is multiplied. The thing that's left out is the division. So it would be 103 times 1201 divided by 298. And I get 415 kilopascals. Let me check online real quick. I'm missing people. This is when you cross multiply and divide, when it's set up like a proportion. That's correct. Okay. We've got literally 5 minutes. through.
I know how to do the job.
Yeah, the gas laws really aren't that bad. I should have put a combined gas law one on here, but I didn't do it. Really? I did not put a combined gas law one on here. All right, well, oops. I didn't do that. I meant to when I was putting this together and I didn't do it. This is another Charles law. For some reason, when you guys are trying to solve for something in the denominator, it messes you up, and I don't know why. It's still cross, multiply, divide.
But we did two.
Yeah, I meant to do a combined gas law, and I yanked the wrong one out of my notes. But, like I said, you guys, for some reason, have an issue trying to solve for something in the denominator. You're still, in this case, you are still going to cross multiply and divide by the thing that is left out. Yeah, I really meant to do a combined one here where it was all three, but I don't know. I yanked the wrong one out of my stoichiometry notes. And then I have an ideal gas law one. PV equals ART.
Can we do the next one really quick?
You all done with this one?
Yeah.
Wait. We're going to be going like right to the bell.
Hey, hold on, which one is this one?
There we go.
Oh, wait, no, I didn't do this one. Wait, this was,
Mm-hmm.
oh, we were finding these.
Yeah, Kelvin. 110 Kelvin. T2.
So what's
We're looking for
T1?
T1.
Oh, it is T1. That's supposed to say T1, not T2. That's a typo. I'll go fix it. I just need to change my subscript.
Oh, what's T1 then?
It is 110. Look, I had the wrong subscript. That's supposed to be a 1, not a 2.
But I'm still confused.
Here,
What do we find?
T1. I had the wrong number written down. No, it goes to 250. So that's a T2. All right, y'all, we still have like 4 minutes. Okay, I still have one more I'm going to show you guys.
Yes, Harold, why are you packing up?
As you're packed up.
All right, so the last one that you guys have that's on here, the ideal gas law.
What was the formula for the last one?
Diabetes.
The last one was V1 over T1 equals V2 over T2. This is the ideal gas law where PV equals nRT.
Wait, so we did 3 of T1?
No, there were 2 of those.
What's the last one?
This is the ideal gas law.
Oh, what's one for that?
That was Charles' law.
No, no.
V1 over T1 equals V2 over T2.
Yeah, we did 3 of them.
Oh, no.
No, we did, let's see, we did Dalton's law, Charles' law, Boyle's law, Gay-Lussac's, another Charles' law. I did mean to do a combined gas law instead of the second Charles' law, but I just yanked the wrong one out of my stuff.
Oh, and this must be pressure.